in general, which is crystalline argente. Good morning, everyone. I am Crystalline Ardiente, and today I'm going to report about the electromagnetism. Next, please. So, guys, I would like you to observe on this figure. Does anyone has an idea what does this figure shows? Does anyone has any idea? Okay. In this figure, you can see the nail was wrapped by the wire and the wire was connected by the end terminal of the battery, and you can see that the nail attract the clips. So, why does the nail attract the clips na dili man magnetic ang nail? Does anyone has idea? Okay, because in here, we will discuss about the electromagnetism wherein electricity can be created into magnetism. So, this is how electricity and magnetism are related to each other. Even though ang nail, dili siya magnet, naka-attract siya sa clips because sa reason nga you can use electricity to create magnetism. Next, please. So, electricity and magnetism. Magnetism produced by electricity is called electromagnetism. So electromagnetism is a branch of physics which deals with the study of electromagnetic force. It can be considered as a science of electromagnetic fields. When an electric current passes through a conductor, a circular electromagnetic field is created around it. The direction of the current decides the direction of rotation of created magnetic field. The current strength as well as the length of conductor decides the force of electromagnetism developed. Then a change of a magnetic field can produce electricity. Because when a change in electric field creates magnetic field, and a change in magnetic field creates an electric field. Next, please. So I would like to give an example. Moving a magnet around a coil of wire, or moving a coil of wire around a magnet pushes the electrons in the wire and creates an electrical current. Electricity generators essentially converts kinetic energy, the energy of motion, into electrical energy. And I want to show you an example video. Next, please. So, today electromagnetism is used in many electronic devices such as our phones, laptops, TV, electric fan, and many more. But before it was discovered, scientists believed that the electricity and magnetism were unrelated. So the electromagnetism was discovered by Hans Christian Ørsted, a Danish physicist and a chemist, in 1820. He discovered the electromagnetism. So let's discover the history on how Ørsted discovered the electromagnetism. Next, please. So the accidental discovery. In 1820, Ørsted was presenting a demonstration to some science students. Ironically, he was trying to show them that electricity and magnetism are not related. He placed a wire with electric current flowing through it next to a compass, which has a magnetic needle. As he expected, the needle of the compass didn't move. It just kept pointing towards Earth North's magnetic pole. After the demonstration, a curious student held the wire near the compass again, but in a different direction. To Ørsted, surprised, the needle of the compass swung toward the wire, so it was no longer pointing north. Ørsted was intrigued. He turned off the current in the wire to see what would happen to the compass needle. The needle swung back to its original position, pointing north once again. Ørsted was discovered that an electric current creates a magnetic field. The magnetic field created by the current was strong enough to attract the needle nearby the compass. So I would gladly to show you the video on how Ørsted discovered the electromagnetism. Next, please.
In 1820, Danish physicist and chemist Hans Christian Ørsted was setting up materials for a lecture. His materials included an early kind of battery called a voltaic pile, constructed of copper and zinc plates in a dilute acid solution, and a wire held in place here by a set of clamps. Ørsted and other scientists of his day knew that when a wire was connected between the positive and negative terminals of a battery, electricity would flow through that wire. Electrons actually move from negative to positive. However, the convention is to think of electrical currents as moving from positive to negative. So that's how we'll show it here, using red particles. Back then, scientists still had much to learn about electricity. Preparing for his lecture, Ørsted made a very important discovery about the phenomenon, quite accidentally. Among Ørsted's scientific paraphernalia was a compass. Its needle, of course, pointed north in alignment with the Earth's magnetic field. Ørsted happened to place the compass near his battery and was startled to notice that the compass needle moved. As Ørsted deduced, this happened because the wire produced a magnetic field around it when it carried a current. If there is no current in the wire, the needle reverts to the alignment with the Earth's magnetic field. As it turns out, an electric current, made up of moving charged particles, produces a magnetic field that circles around the moving current, as shown by these blue lines. If you reverse the direction of the current, then the magnetic field around the wire moves in the opposite direction, and the needle on the compass flips to reflect the change in field. If you move the compass to a new spot near the wire, the needle will realign with the direction of the magnetic field in that particular location. Ørsted's accidental discovery was solid evidence that electricity and magnetism were related phenomena. The announcement of his findings incited a tremendous outbreak of research in the nascent field of electromagnetics in the early 1820s.
So out of curiosity jud ay maka-create ta og something new and discovery, like how Christian as they discovered the electromagnetism, wherein ako tungod lang sa usa ka compass and out of curiosity sa usa ka estudyante na create ang idea sa electromagnetism and na prove that magnetism and electricity are compatible to each other. So next please. So electromagnetism is governed by the basic law known as Faraday's law of induction. According to Faraday's law, the induced electromotive force in any closed circuit is equal to the negative time rate of change of magnetic flux enclosed by the circuit. The law shows how a magnetic field interacts with an electric current. Next, please. Electromagnetism help in establishing the relationship between the electricity and magnetism. So the relationship of electricity and magnetism, that the electricity and magnetism, the magnetic field induces the electric charge movement, producing an electric current in an electromagnetic wave. Then the electric field and magnetic field are perpendicular to each other. So that is the relationship between the electricity and magnetism. Next, please. So the electromagnetism created can be turned on and off by cutting off the electrical current flowing in the conductor, like on switching on and off our light bulb. So when we cut off or we switch off the switch, so it will cut the electricity flowing on the conductor. Next, please. Electromagnetism also causes radiation, which shows up in an electromagnetic spectrum. Electromagnetism has been extended to quantum physics. It has helped in finding related to the nature of lights and the discovery of electromagnetic spectrum. And in here, I would like to show you a video, but before that, I would like to continue first my discussion. Next, please. So electromagnetism is also used in devices such as speakers, solenoids, electric motors, and magnetic disc. So that's how electromagnetism is useful nowadays to create electricity. So daghang kay siya use sa atuang balay, which is everywhere na tumakitaan. And I would gladly to show you a video.
Electromagnetism, or the electromagnetic force, is one of the four fundamental forces of nature. It generates light and energy and holds atoms, matter, and the world as we know it together. Electromagnetism is a branch of physics that studies the interactions between electric and magnetic fields. All matter has an electric charge, which can be positive, negative, or zero. Opposite charges attract, while like charges repel. These electric forces bring and hold atoms together. And when atoms gain a positive or negative charge through the transfer of electrons, a measurable electric field will form. If those electrically charged particles start to move, the field will become a flowing electric current and form a magnetic field around it. Under the right circumstances, interacting electric and magnetic fields can continuously produce and sustain one another. This generates an electromagnetic field that transmits waves of electromagnetic energy or radiation into space. The intensity of this radiation is determined by its frequency. These frequencies make up what's known as the electromagnetic spectrum. Near the middle of the spectrum is visible light, such as light emitted by stars, fireflies, and computer screens. On either side are invisible electromagnetic waves. On one end are long, low-frequency radio waves that broadcast television and radio signals, microwaves that carry telephone signals and cook food, and infrared waves emitted by fires. On the other are short, high-frequency wavelengths, ultraviolet, X, and gamma radiation. Unlike low-frequency waves, these waves can pass through the human body, making them useful for medical applications. While electromagnetism has daily applications, it's also the engine that drives the planet as a whole. Thousands of miles below the Earth's surface, a layer of liquid metals churn and flow. This generates electric currents that then produce magnetic fields that all together encompass the entire planet. Called a geodynamo, this process causes Earth's poles to attain positive and negative charges, turning the planet into a giant electromagnet. This phenomenon also creates a protective layer around the planet. It shields us from the most harmful radiation in space, leaving us to enjoy a world held together by the strange and fundamental force of electromagnetism.
Okay, that will be the end of my topic about the electromagnetism. To understand more about it, let's go to electromagnets that will be reported to Miss Duran, Jamaica Marie. Thank you, Miss Argenti. Good day, everyone. I am Duran Jamaica Marie, and I am here to report about electromagnets. So, kabaw naman tatanan unsa ng electromagnets. But kabaw ba mo nga ang ubang electromagnets kay pwede siya ma-turn on and off? One type of temporary magnet is called an electromagnet. So, what is electromagnets? Well, the hint is in the name itself. Electro for electrical and magnet for, of course, a magnet. So, next slide. So, let's take a moment to look at the definition of what an electromagnet is. Electromagnets are materials that become magnets in the presence of electricity. So the next please. So let's have electromagnets is a science of charge and of the forces and fields associated with charge. Electricity and magnetism are the two aspects of electromagnetism. So, how are electromagnets made? But how does that even happen? Well, it turns out that electrically charged particles in motion actually have small magnetic fields around them. So if we run electricity through a wire, a magnetic field will be created around the wire. Next, please. Electromagnets are made of coils of wire with electricity passing through them. Moving charges create magnetic fields, so when the coils of wire in an electromagnet have an electric current passing through them, the coils behave like a magnet. So as you can see in the picture, this is an illustration of an electromagnet. Next slide, please. So let's have the importance of electromagnetism. Electromagnetism has important scientific and technological applications. It is used in many electrical appliances to generate desired magnetic fields. It is even used in electric generator to produce magnetic fields for electromagnetic induction to occur. Next. So here are the characteristics of electromagnetism. Electromagnetic waves are typically described by any of the following three physical properties. So let's have to take note of that. So we have here frequency. wavelength, or intensity. Next slide, please. So, here are the principles of electromagnetism. Faraday's principles of electromagnetic inductions states that EMF induced in a loop due by a changing magnetic flux is equal to the rate of the magnetic flux threading to the loop. The magnetic flux threading a coil of wire can be changed by moving a bar magnet in and out of the coil. So let's have the principles, Faraday's principles will be discussed further later. So what are the four laws of electromagnetism? We have the four laws of electromagnetism. They are Faraday's law, Ampere's law, Lenz's law, and Lorentz force. Next, please. So, coiling a wire to form a solenoid will also increase the strength of the magnetic field. The strength of the magnetic field will also created by a solenoid is strong and uniform throughout. So, to increase the strength of the magnetic field around the solenoid, so we have here a picture of a solenoid. So, we can add an iron core, increase the number of coils in the wire, increase the current passing through the wire. Next slide, please. Now, we can control the strength of this magnetic field in couple of ways. We can move more electric charges through the wire at a faster rate. And we do this by increasing the electrical current, so just like that. The second way is to increase the density of the charged particles. And we can do this by looping the wire into a coil. This will give us more charged particles with the magnetic fields in a small space, strengthening the magnetic force. The other thing we can control with electromagnets is the direction of the magnetic field, and we can do this by changing the direction of the electricity. So if we go back to the wire example from earlier and change the direction of the electricity running through that wire, well, the magnetic fields will also change its direction. This makes electromagnets quite different from permanent magnets. Next slide, please. So let's take a look at that and compare permanent magnets to electromagnets. Electromagnets are typically made of loops of wire and a coil. The wire is typically made of a metal like copper and wrapped around pieces of metal like iron, nickel, or cobalt. This is different from the permanent magnet because permanent magnets don't need this wire. Permanent magnets also have fixed poles. You can't change the north and south poles on these magnets, but as we now know, for electromagnets, we can change these poles by changing the direction of the electrical current. So if we have an electromagnet with a north and south pole that looks like this, and a current flowing in this direction, well, we can change the poles and the direction of the current. Permanent magnets have a fixed strength, but we just talk about how we can change the strength of electromagnets. So, Electromagnets have adjustable strength. And finally, electromagnets need a power source in order to generate the electricity required to produce magnetic fields, while permanent magnets do not need a power source, but this means that we can also turn electromagnets on and off, which is pretty cool, pretty basta nindot siya when you think about kung imo na siyang huna-hunaon. So, on the other hand, permanent magnets kay always ra siya mag-on. Next slide, please. So now you might be thinking if electrical charge can affect magnetism. Can magnetism affect electrical charge? Absolutely. Let's take a look at how we can do that. The only way to do this is by changing the magnetic field around the charged particles, and this can be done by moving magnets closer or farther away from the particles or by spinning the magnets. In fact, spinning magnets is how most of the electricity we use in cities and homes is generated. So we have here the South and North Pole in the graph and the illustration of a magnet that is spinned. So for example, we have a turbine. A turbine spins a magnet inside a coil to produce electricity. And since electromagnets need a power source, as mentioned earlier, this turbine is powered by wind. Next slide, please. So you can see why electromagnetism is an incredibly important force, and this isn't the only important application of it. We use electromagnets in all sorts of other applications, from motors to speakers and even medical scanners. So electromagnets are widely used in electric and electromechanical devices, including the following. So let's add there the magnetic recording and data storage equipments like tape recorders, VCRs, hard disks, and the MRI machines in the hospitals. Next slide, please. So now, let's analyze electromagnets. We have a sample problem here. At the Science Museum, Mark finds some stationary bikes with magnets attached to their back wheel. When Mark pedals a bike, the magnets on the wheel rotate through a coil of wire, and this produces an electric current that lights up a series of light bulbs. He then pedals a bike at the same speed but with weaker magnets on the back wheel. So, how can you analyze that situation? So, as mentioned earlier, using a bike with weaker magnets would not affect the electric current generated. Why? Because the magnetic field around the wire changes. It generates an electric current in the wire. The amount of wire electric current generated in the wire is directly related to how much and how quickly the magnetic field changes. So another thing is when Mark pedals the bike with weaker magnets, he creates a smaller change in the magnetic field around the coil of wire.
this smaller change will decrease the electric current going to the light bulbs. So we have another reason is that pedaling a bike with weaker magnets would decrease the electric current generated. Thank you, and that's all for my report. And let's move on to another topic tackled by Miss Egos.
All right, thank you so much for that insightful discussion, Miss Duran. So, hi everyone. Good morning. My name is Agos Donna Marie. I'll be discussing to you what are the electromagnetic forces. So, are you sitting in a chair right now? What is keeping you from falling through the chair all the way to the ground? If you could suddenly shrink and become as small as the atoms in the chair, you would see that the chair, just like all matter, is actually mostly made of empty space with some very tiny charged particles floating around it. So, it is the interactions between these charges that make the chair feel solid and keep you from falling through it. Electromagnetic force can be used to understand and explain how charged particles like those in your chair interact with each other. So the electromagnetic force is one of the fundamental forces of the universe, and it affects our reality in some profound ways. So what are electromagnetic force? Electromagnetic force are responsible for holding atoms together in solids and liquids, creating friction forces that allow you to walk across the room, producing light and radio waves, generating electricity, and so much more. So to understand electromagnetic force, these are forces that hold atoms together in both solid and liquid materials for these materials to become strong and sturdy. So the electromagnetic force is a type of physical interaction that occurs between electrically charged particles. It acts between charged particles and is the combination of all magnetic and electrical forces. So the electromagnetic force can be attractive or repulsive. It is also called the Lorentz force. So electromagnetic force is also called Lorentz force, or another term for electromagnetic force is Lorentz force. So, before the invention of electromagnetism, people or scientists used to think electricity and magnetism are two different topics. The view has changed after James Clerk Maxwell published a treatise in electricity and magnetism in the year 1873. The publication states that the interaction of positive and negative charges are mediated by one force. These observations laid a foundation for electromagnetism. So later, many scientists like Michael Faraday, Oliver Heaviside, and Henrik Hertz contributed to their ideas in electromagnetism. So before now, electromagnetism or electricity and magnetism are viewed as two different aspects or sides of science. However, big thanks to James Clerk that he published his book of a treatise in electricity and magnetism, he was able to determine the relationship between magnetism and electricity, that they have both the same behaviors in terms of their forces and so on. So one special case of the electromagnetic force when all charges are point charges or can be broken up into point charges is Coulomb's law. So Coulomb's law is a very fundamental law in the electromagnetism. So Coulomb's law states that the electrical force between two charged objects is directly proportional to the product of the quantity of charge on the objects and inversely proportional to the square of the separation distance between the two objects. So in equation form or in mathematical form, Coulomb's law can be stated as F is equal to K times Q1 Q2 over R2, wherein F is represented by the electrostatic force, K is constant, which is 9 times 10 to the power of 9 Newton meter squared over Coulomb squared. Q are the forces, and R is the distance. So please take note of the formula because it will be very relevant to the electromagnetism. So let us practice. Given this information, there are two charges, which is positive 5 times 10 to the power of 3 Coulomb. The other charge would be negative 1 times 10 to the negative 1 Coulomb. And the 0.5 meter there is the distance between the two charges. So the given would be K is the constant, which is 9 times 10 to the power of 9 Newton meter squared over Coulomb squared. Q1 would be positive 5 times 10 to the power of negative 3 Coulomb. Q2 would be negative 1 times 10 to the negative 1 Coulomb, and R is 0.5 meters. So let us substitute the given values to the formula, wherein 9 times 10 Newton meter squared over C squared times the two forces, which is 5 times 10 to the power of 3 Coulomb, multiplied to the other force, which is negative 1 times 10 to the negative 1 Coulomb. So 9 times 5 would be 45 times negative 1 will be negative 45. However, in Coulomb's law, there will be a imaginary absolute value between the two forces. So the two forces should be positive, always positive. So 9 times 5 times negative 1 equals negative 45. But the absolute value of negative 45 is equal to 45 times 10 to the power of 9 minus 3 would be 6, and then minus 1 would be 5, all over 0.5 meters squared. The 45 times 10 to the power of 5 Newton meter squared, because we have canceled the two columns here, all over 0.25 meters squared. So the final answer would be 180 times 10 to the power of 5 newtons, or in scientific notation, that would be 1.8 times 10 to the power of 7 newton. Okay, so that's it for me. So I will now introduce you to the next presenter, which is Rafa, for the Faraday's law.
Good morning. My name is Rafa. Topic is about Faraday's law. Pero before ko mag-start, I want to ask if madungog ako. So, history and background. So, Michael Faraday, born to a poor family in Newton, England. He became an errand.
Excuse me. Please try to check your audio. Kaya murag medyo hingay ra gyud. Thank you.
Hello? 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 Madungog na? Hello? Madungog akong voice karon.
Okay.
Okay na, ma'am?
Yes, I think magpaduo lang siguro ka sa kung doon na ka din, Mike. Magpaduo lang kay para maklaro kay medyo hinay ra ganina. Thank you.
Okay. History and background.
Please introduce first yourself. Unahan lang imong apelyido para I can check here. Sa kadapita kay dili man gud mo in sequence nag-present, no? Okay, so palihog lang apelyido first.
Sorry. Good morning, everyone. My name is Rafa Elijah Lamada. Um, my topic is about Faraday's
Medyo
law.
nihinay na po imong tingog, miss. Okay. Sige.
Good morning, everyone. My name is Lamada Rafa Elijah, and my topic is about Faraday's law. So about Michael Faraday, he is born a little bit of his past background, history and background. He is born to a poor family in Newton, England. He became an errand boy for a bookbinding shop, and he reads every book that he found. Next, he became interested in the concept of force, or specifically force, great experimental physics and chemist. Next. So contribution to early electricity include invention of motor, generator, and transformer, electromagnetic induction, laws of electrolysis, a method of separating bounded elements and compound by passing an electric current through them. Next. So electromagnetic induction. Electromagnetic induction is the process of generating electric current with a magnetic field. It occurs whenever a magnetic field and an electric conductor such as a coil of wire move relative to one another. So electromagnetic technology began with Faraday's discovery of induction in 1831. So next electro electromagnetic his demonstration that a changing magnetic field induces an electric current in a nearby circuit showed that mechanical energy can be converted to electric energy. So another meaning like electromagnetic induction occurs when a circuit with an alternating current flowing through it generates current in another circuit simply by being placed nearby. An alternating current is the kind of electricity flowing through power lines and home wiring as opposed to a direct current which we get from batteries. Next. So this is like an example of experiment. So si Faraday, he had proven that magnet could induce or makabuhat siya og electricity. So this is the example or the experiment how it all works and how it induces electric current. So as you can see here, is that when a current passes through the coil, it actually generates a magnetic field around it. So makita ninyo kanang naay magnet nga iyang gi move near sa coil, ni start na kanang generate og magnetic field around sa bar magnet, and kay ba mo anang dili siya visible pero kay ba mo kanang magnetic field kay mo na siya kanang zigzag og tan-aw mo card kay kanang makuanan og magnet ang like and ay zigzag mo appear mo na siya ang kuan magnetic field na niya appear, and then means an electric current can give us magnetic field. So this is how Faraday have actually thought that pwede sa di ay nga ang magnetic field can create electric currents kay di ba we use batteries, then ang like more thought to siya ba nga alternate siya sa battery, and then sa experiment ni Faraday, he used a coil with some current sensing device that could tell us whether there is a current flowing or not. And also nag-use si Faraday of galvanometer kanang naay more numbers arrow, and which can tell you whether a current is flowing, and it can also tell you depending on what direction the deflecting is or asa iyahang turn the pit or to what direction the current is flowing. And so for the magnetic field to induce electric current to happen, we need a magnet. So mao na siya na ay mga na ay magnet there as a picture, and the magnet was placed close sa coil. But it doesn't happen pa that way kay if ang magnet is at rest, like imura siya gi-steady ba, like if ang magnet kay naka-steady ra sa coil, wala electric current ni flow, and na ay magnetic field but wala current ni flow if ka-steady ra ang magnet. But if you try moving it, mao na nga ni-induce siya og current. So in short conclusion, ani nga experiment is if you move the magnet closer, the magnetic field strength increases. So in as well that if magnetic field is passing through a loop is what produces electric current, and steady magnetic field does not produce electricity. So kani nga phenomena is called electromagnetic induction, in which when you change the magnetic field to through a coil, it induces a voltage or a current. So same as battery alternator siya, and mas better, and that mo na siya ato pong use currently. Next. So, mo na siya ang equation, formula of the induced EMF ni Faraday's law. The equation that is associated with the Faraday's law of electromagnetic induction is mo na siya ang formula. The induced EMF is equal to negative n times the change in the flux divided by the change in time. Next. So, an example, a square coil of 20 cm of wire consists of 50 loops. The magnetic field is perpendicular to the face, and the coil increases from 80 to 50 in 10 seconds. The coil connected across a 20 ohm resistor. So the question is calculate the induced EMF. So the induced EMF is equal to negative n times the change in the flux divided by the change in time. So the faster and the flux changes that is in the magnetic flux, the greater the induced EMF will be in the second coil, and a change of magnetic field leads to a change in magnetic flux, which will give rise to induced EMF. So given nga ang n is negative 50, and then there is an equation here for the magnetic flux nga BI cos theta, so mo na siya ang negative 3, and then 20 cm times 20 cm cos theta divided by 0.10 sa time, and that will be equals to negative 160 current or volt. And then next, another Faraday's law is the Faraday's law of electrolysis. Electrolysis is coined from two words, electro and lysis. Electro, which means electric, and lysis means breaking down. So meaning that electrolysis is talking about breaking down of something by electric current. However, it is defined as the breaking down of a compound by passing direct currents to sheets by electrodes. It means in order to pass direct current to it, it must be through some rod called the electrode. So mo na siya pass. It's duha ka stick. So how is this done? So a cell, which is a source of current, is connected to the electrode, which current enters the substance, and the substance that we are talking about here is which we are going to break down must always be in liquid form. So term used in electrolysis is first electrolyte. Electrolyte is a substance in which when it is in solid state, it doesn't conduct electricity, but once it is dissolved in a solution form, or it is a material that can be dissolved in water and any other solution, then it becomes electrolyte. It becomes a conductor of electricity. So second is Electrodes are two metal rods inserted into electrolyte through which current enters and leaves the electrolyte. So again, electrolyte is the breaking down in the electrolysis. The substance where we are trying to break down to separate into its component is electrolyte, and it starts to be in a liquid form. And so the electrode is in two types. There is cathode and anode. So the cell of which is the source of current, and it has the negative and positive terminal. The positive is connected to the means of conductor to a rod which is anode. As anode is the positive electrode to which current enters the electrolyte. Then the negative side is connected to cathode. So cathode is negative electrode through which current leaves the electrolyte, and we have the container in which electrolyte is present, and then the electrode is inserted. So the whole diagram here is what we call the electrolytic cell. Electrolytic cell makes use of the chlorine to perform a function which is peeling down of the electrolyte. Next. Wala pa back sa back. So in this case, I have thought of a statement that electrolytes control electricity only in their liquid state, but not in their solid state, because the ion present in the substance are held together by electrostatic force, and this kind of force prevent their free movement in solid state. So in result, they are unable to conduct electricity, but once they are dissolved or molten, the electrostatic force between them loses and they gain free movement in the solution. So um on electrolytes, once they are dissolved in water, there is a free movement of ions when they are dissolved, and through this they can conduct electricity. So if we're talking about the Faraday's law, this is how it have effect on the quantity of hydrogen or whatever that might be discharged. Next. So, or whatever that might be discharged during electrolysis. So how long when you pass current in a short period of time does needs to give. So we tackle about the relationship between the amount of current you pass, the time, and the mass of the elements that will be charged during the electrolysis. So Faraday's law of electrolysis has two laws. There is the first law that tells us the relationship between the mass of elements discharged and the quantity of charge passed through it. However, it has to tell us what charge charge. So if I pass the current I, which is the current through an electrolyte, and T, this is the time that there is a change developed in that process, and that change is given as the Q charge measured in coulomb, and so the charge can be determined as current times time. So current times time is the charge developed when you pass the current. So Faraday want to tell us that the quantity of mass of element discharged during electrolysis is directly proportional to the quantity of charge that passes through the electrolyte. Next. So this is Faraday's second law. The mass of a substance deposit are liberated at any electrode on passing a certain amount of charge is directly proportional to its chemical equivalent weight. So the same current is passed through two different electrolytes takes into consideration. So to siya is the same current is passed through two different electrodes to take into consideration that NaCl and so the sum amount of current passed through with the same amount of time. The relative number of element moles discharged is inversely proportional to the charge on the ion of those elements.
Right, thank you so much for that, Rafa. And now we're down to our segment, or we're down to our where we will be assessing if you really are listening to our discussion. So we would appreciate if you can participate with this small Q&A. So if you would like to answer, please unmute yourself and say your name, because I may not be able to see if who are raising their hands, okay? So the first question, or the first one, is it is considered as the science of electromagnetic fields. Who would like to answer for the first question? Anyone? Please unmute yourself and say your last name.
Arabis,
Arabis, what's your answer?
electromagnetism.
That's right. Your answer is correct. Electromagnetism is the science of electromagnetic fields. Second, Danish physicist and chemist who discovered electromagnetism in 1820. Anyone? Yes, please unmute yourself.
Faura
Aura, what's your answer?
Hans Christian Ørsted.
Yes, you're correct. Hans Christian Ørsted. The third question, what are electromagnets made? Yes.
Slips, holes of wire.
Yes. Right, that's correct. Electromagnets are made of coils of wire. Next question, another term for electromagnetic force. Anyone? Yes, Taneo.
Lorentz force.
That's right, you're correct. Another term for electromagnetic force is Lorentz force. Next would be, it is a process of generating electric current with a magnetic field. Yes, Villanueva, what's your answer?
Electromagnetic induction.
Perfect, your answer is correct, electromagnetic induction. Next question, the mass of a substance deposited or liberated at any electrode is directly proportional to the amount of charge passed. What could be the correct answer for this? Yes, Federicos.
Faraday's first law of electrolysis.
Correct. Faraday's law, first law of electrolysis. So next and the last question, the mass of a substance deposited or liberated at any electrode on passing a certain amount of charge is directly proportional to its chemical equivalent weight. What could be the correct answer for this? Yes, Angelica, what's your answer?
Faraday's second law of electrolysis.
Perfect. Your answer is correct. All your answers are correct. So that means you really listened to our discussion. So that would be all. Thank you so much for listening, everyone. And if you have other questions, or if you want to know more about our discussion, the reference, or there will be the reference here, you can visit these links written. Thank you so much.
Okay, thank you, presenters. Thank you, listeners. Do you have questions here, listeners? Or maybe we can ask the presenters if they were able to prepare questions for the listeners. Did you? So if not, then I'm going to call na lang, no? So, I'm not so sure asa ni nabilong kani akong tawagon. Batukan Darwin, Faura Reynalyn, Jabel Devrilet, Jimenez Clarence, Ortez Melvin Nick, Pungautan, Gia Erica, Restauro Angelica, and Tribulano. Actually, wala pa mo'y rating diri sa akong list, no? But then, ako na ning checkan, it means nga, naka-present na mo, but you were not rated yet. Kasi akong gipang tawag. There are, how many of you here? 1, 2, 3, 4, 5, 6, 7, 8, 9 kabuok. O, asa naman ni sila akong gipang tawag? Ganun wa may tingog.
Kami to ang katong kami tong
Yes?
reporting, miss, katong first nga reporter nga nag-recording.
Yes, miss.
Okay, so ato lang yan ng paminahon ang inyong recorded presentation, ha? Kanang maybe week after next week, ato na siyang paminahon. Kay, para i-play na ninyo during yun sa atong virtual meeting. Okay ra? I-andam lang na ninyo, ha? Because wala pa man ko nagpa-submit ninyo, ana, right? So, i-keep lang na ninyo, then during sa atong virtual meeting, puhon, inyo na siyang i-play para you will have here rating. Now, ang nahabilin na wala pa ka-report are the following. Akong basahon, Rituerto, Sumalinog, Villanueva and Diaz. Sumalinog, Rituerto, Sumalinog, Villanueva and Diaz. Upat ka buo. You belong to Group 8, I'm sure, right?
Excuse me, miss.
Yes?
Si Diaz, miss, kay dili na Group 8.
So asa man ni siya nga grupo na belong?
Group 6 namin katong ni-report din na.
Excuse me, kanang Alexa, dili maklaro ang imong tingog day, murag choppy ra kaayo. So, aliho ko kusga aron maklaro nato, make it loud and clear. Ang imong audio i-adjust.
Padungog na ko, ma'am.
Yes.
Si Vanessa Diaz, ma'am, kay ka-group na siya namo, which is Group 6 katong ni-present kanina.
I see. So, adira, no? So, naaman sa tsingan, gudiri sa ubos. So, humana ni siya. Therefore, tulo na lang ang wala ka present. Right?
Excuse me, miss.
Yeah, I think we still have enough time. Yes? Mr. Jerome?
Si Macasero Angelica, miss, kay Group 8 siya, miss. Wala ni mo na storya. Upat may kabuok.
Macasero Angelica. So, upat mo kabuok. Nga kung mo present mo karon dili na pwede. No?
So, sa time, miss. Pero,
Yes, dili na, no? Kay upat na mo kabuok. Pero tagpila man mo, di ba, tag 10 minutes only?
yes,
Maximum
miss.
time ninyo is it 10 minutes? So, napabatay 40 minutes? Wala na, no? Malapas na ta sa alas 12. Okay, anyway, kuha na lang, no? Kay next week class, I would like to inform you that next week, Wednesday, Wednesday, Thursday, and Friday, we will be going to Bulhoon for the strategic planning para sa eskwelahan, para sa College of Arts and Sciences. So, as regards to this, wala mi mahimo but to be with them kay gi-required ang tanang faculty members sa CAS, no, sa College of Arts and Sciences. Therefore, we were instructed to have this asynchronous classes only, meaning no virtual meeting next week. So, ang atong buhaton is, ang Group 8, mag-ready lang mo. Anyway, di pa man ko makahatag og midterm grade And I think matingog na para sa final grades, although I'll be computing your midterm grade, no? Pero encode na ako, final grade na dito. What's the reason for this? Because there were those nga wala pa sad ka-take og midterm exam niya. Kaning inyong oral presentation ako sad ni siyang humanon because that is one of the requirements for the computation of your midterm grade. So, bali, next week, asynchronous ta, i-ready lang tanan ninyo for submission. Maghatag ko sa mayor of this section sa instruction on sa ibuhaton sa inyong mga written reports. So, ako nga nang i-text ninyo this coming Sunday siguro or Monday. Then, i-ready na ninyo, i-submit. Kaya para inisunod na itong balik, submitted na next week. Then, week after next week, class, mauna na siya atong Wednesday, no? After next Wednesday, next week, that will be our last day for the presentation only. So, mag-present mo ang Group 8 at the same time, i-play nila ang recorded presentation sa, I think, is it Group 5 and Group 4?
Yes,
Doon
Miss.
ka grupo, class? Okay, so kinahanglan mahumana nato tanan sa usa lang ka meeting Wednesday after next Wednesday. So klaro, unya in this section mangutana ko kinsa may questionably ang midterm exam. Because naamang gusto yung mga students na ni-text na ko, unya when I answer them, when I send the messages sa akong reply, send to all mangguna class sa tanan akong klase mo, automatic na siya send to all. So, I'm not so sure kung kaninga section na aba ni dini wala sad ka take og midterm exam. Okay, so unsa man? Hello? Wala na may naningog. So, ang tanan naka-take og midterm exam.
Yes, Miss.
Sige, wala na problema. So, i-disregard lang to ang message na na-receive ninyo from me regarding sa midterm examination, no, katong wala ka-take. Okay? So, and then after nata sa tanan good class na after na sa tanan na discussion ninyo or presentation, I'll be giving my summary of discussions because there were those topics being presented na murag medyo na ay mga nakuwang bitaw nga mga importante nga concepts. Okay, so for now, we will be off kay dili naman mada sa group 8 ang pila na lang ka minutes. Okay, so napay laing concern coming from the listeners? Questions?
Good morning, ma'am. Ma'am, moasan tami about sa katong value
Yes.
of nani, ma'am. Kay majority of us kay gigamit manggod ma'am kay 9.81, then dili ra to pwede i-reconsider, ma'am.
Unsa to siya nga problem?
Prag katong lifting, ma'am, nga murag force.
Yeah, maka-affect ang value nga 9.81 sa answer.
Yes, ma'am. Kay
Dili ra.
ko if 9.8 siya, ma'am, maka-affect siya, ma'am.
Kung
Kay 9.81 kay murag sa mama ako compute, ma'am.
Sige ko no. I-check.
If
Kay answer naman
9.8
akong gipahatag ninyo ato.
If 9.8, ma'am, kay ang answer kay 5,880. Then if 9.81 kay 5,886 ang answer, ma'am.
Mao ba sa 0.00 sa 0.01 na difference? Ma-affected lang di gyapon ang value. Sige, ako lang yan na siyang i-check. Okay. So any other concern? Wala na ilain. Wala na, miss. Okay, so kung wala na ilain, then you can take your lunch early today. Okay, so if there are no other concerns, thank you everyone. Then, magtanaw na lang mo sa atong GC ha, palihog. Then, who is the mayor of this section? May I know? Sa tutoy mayor sa section? Hello? Mayor of this section?
Si
Will you
Jared.
please tell me your name? Yes, unsay mo apelyido dong? Family name? Mayor of this section? Absent?
Si Jared Sumalinog, Miss.
Absent siya ron? Sumalinog? Are you around or absent?
Wi-Fi, Miss.
Unya, naa siya, wala?
Na-out siya, miss.
Naamis.
Naa?
Miss. Naamis.
And then, karon pa ka ni attendong sa klase?
Nalive ko gani miss pero kuan miss. Naaro ko miss.
Anara ka.
Hindi ko madungog gani miss.
Ako niya tikang textan ha regarding unsay mga submission, unsaon pag-submit, asa i-submit, then unsay buhaton para na siya sa next week dong kay mag-asynchronous ta. So I won't be meeting this section next week virtually. So asynchronous lang, mag-ready na lang mo sa tanan. So kadtong wala pa kahimo sa ilang written reports. Pareha karon na may nag-present, maghimo na sad mo. Paghimo na dayon mo para next week na ana mo'y ma-submit sa Wednesday. Okay? Naklaro class?
Yes miss.
Yes, miss.
Okay, so kung wala na concerns, if there are no other concerns, then the class is dismissed. Thank you everyone.
Thank you, Miss.
Goodbye. Thank you miss.
Thank you, Miss.
Okay, I'm going to leave now.